Welcome everybody. Today is the first session that we are going to discuss and do a deep dive on sensor data about how to store sensor data with timescale and mainly show like a suggestion or a template for it. So my name is Jonatas. I am a developer advocate and also a community manager at Timescale. And I live in Brazil, and I decided to organize this session as a call to action to the community. So I am, as a community manager, I see a lot of folks asking things and asking a lot of questions about how to store data and how to use the best practices. So the idea here is like we join folks from different industries and let them also speak about their experience and see if we can come up with a template that can speed up the adoption in different areas. So community is always requesting like, what is the most optimized settings for my case and my scenario and so on. So we have been building a lot of content about it. And the main idea is that we can also try to bring it as a template. So everybody wants to have this most optimized space, right? So why not build it as a community? So as a community, it will be much easier to understand what are the constraints of your domain and let it work with like shared standards. So everything that we are going to see today is going to be alive on this repository, github.com/timescale/templates. As an inspiration, you can take a look and find us there. And today is about sensors data. So an opinionated template for sensors data, something that we can start. So this is our first session. Tomorrow is the fourth session for finance. So if you are also interested in like tracking stock prices or crypto prices or like building your market data pipeline, that's also a new opportunity. But we are recording these episodes. You can also find it later on YouTube, and that's a thing that you can also do. So this is the call. Why I'm asking you several times to build it as a community. So use the chat, start sharing, and let's say knowing other folks here. So the chat here in this webinar is not the best because this is like it's just like hiding other folks and participants. So we have a few dozen participants in this meeting, but you cannot see each other. But if you say something, people will be able to also comment. And I would say you can also do the same asynchronous on our TimescaleDB Slack community. So if you are not there, if you just come from our social networks like LinkedIn or Twitter, just also join our Slack. This is the place which like discussions happen also live, and we have a discussion sensors channel which we are discussing and putting our information for these calls and everything. So what's the hardest part to configure in the TimescaleDB extension? So use the chat, share your opinion, talk with others. I will not be checking the chat very much here. I will just leave it when I go to the questions. So feel free to share, feel free to join a chat with other folks, and also be commenting on the things that we are building here, because we are a community. We can help each other, we can learn with each other, and we really want to collect this experience. I will be like an instrument of these meetings to be collecting this information and bring it as learnings, tips and tricks and things that we can be transforming this knowledge into some educational content. How does your data sensors data arrives in the DB? So maybe you use some cool tool. Maybe you have like a very nice library that does what you need. Maybe you build your own custom batching system. Share your experience, share with the other folks. Maybe you use this the same tool. Maybe you find folks that have similar needs and you can start building something together. So that's all about connecting folks and doing this networking. So if you are interested in growing and enhancing, always remember that community is a great path to be sharing knowledge and also sharing expertise. A lot of folks here are very open for sharing expertise, and they will be very happy on sharing and learning with each other. Talks cheap. So let's go and have some fun and analyze some code and start our real session. So when we talk about timescale, we talk about hypertables, and hypertables is the core, the heart of everything in timescale. Hypertables are basically a metadata that you install to say that your table will be automatically partitioned, and Timescale inserts some very lightweight mechanism that hooks the inserts and just split it to the table depending on the time column. So you just say, this is my table, this is the time column, and it can split and partition your database on this. So the simplest example that we can say on IoT is like, well, I have a table with a timestamp and a device. I don't know what the device is this. So this is like an identifier. And then I have some float value that's coming like a sensor, like humidity, temperature, or any other types of sensors. And that would be a very, very minimal hypertable for this case, right? So on Postgres, we also have JSON-B. And Timescale plays very well with anything that's Postgres. So it's just an extension. We are not changing the Postgres itself. So Timescale is very easy to go. And you can also define different ranges. For example, maybe you want to have your hypertable split by 1 day or by 1 month or by a few hours. So as soon as you understand how your data flows in the database, you can start looking closer or looking closer to these configurations and learning what works best for you. We are going to cover it briefly today, but in a future session, we are also going to go further on the chunk time interval and how you can split your data in a most efficient way. So this is another example, very simple, like you can just define a table, very generic, that accepts any JSON-B, so you can put any data there, any payload, and you can also segment by origin and have this extra identifier that can help you in several ways. Now I would like to introduce our friend from the community, Facundo, that was also a person that triggered and started the discussion of bringing these sessions early. So he joined the finance discussions and say, hey, I'm interested in doing it for sensors. And I was like, let's do it. So we even anticipated the sessions because we can start early as we can. So this is the model that Facundo brought. So Facundo, feel free to take over and share, and I can be following the slides. So
sure.
And
Thanks.
feel free to introduce yourself as well.
Yeah, I'm Facundo Etchezar. I'm a software developer at Pan American Energy, which is an oil and gas company from Argentina. Our field is that is oil and gas, which means that all our sensor data is on the field. Think a big desert with a lot of installations spread throughout. And these massive oil wells and stations and water injection plants that are big, have a lot of sensors, a lot of industrial sensors that are constantly transmitting data. Since the oil field is quite big, there is a lot of value for basically every oil and gas company to be able to sample that data from afar, because it means you can have supervision and prediction and all sort of things by analyzing that data and not going physically to the installation, which can be very expensive. You have a lot of people and vehicles and safety precautions. So all of that is great to have all this data concentrated in a single database for everyone to inside the company to use. This is like an abstract view of our base model. Installations are quite complex in oil and gas. They have a lot of distinct parts, and they use a lot of industrial protocols, which are quite expensive. So not all of our solution is open source and free. Specifically, the part that connects to the installation in the field is a proprietary gateway that understands all the industrial protocols like OPC, Modbus, LM, etc. So all of that isn't done by your usual MQTT or some free tool, but rather that needs quite an expensive piece of software to connect to the field. However, when you build upon that, you have once you connect, you have the data. You have these divisions of this installation. We don't segment by sensor because each installation has tons of sensors. So the segmentation by sensor is too fine grained sometimes. So you have a catalog of installations. The installation, it's important to have a unified catalog in the whole company because you want applications to have very little friction querying this data. Installations are quite diverse, so there are a lot of systems inside the company that have managed these different kinds of installations. So having a unified catalog, which can be as simple as what you see, which is an installation table with a primary key and just a name, is quite important because that ID is what you use in your own applications to relate to that installation. So every small or big application that comes after this can use that unique ID as the main catalog of all the installations in the company and refer then to historic data down the line. The idea is that while you have your unique catalog of installation, which has everything, which again can be as simple as this, you can create peripheral tables besides this that have metadata that accompany your installation. So you have can be like I say, can be an oil well has a lot of more fields. But once you have your installation catalog, which in your case is synchronized and replicated across all our historic databases, now you get to the specific part when an installation has a certain amount of signals related to that. An installation, in our case, can have anything from 100 to 1,000 or even more signals because, again, a big installation like a station is a big thing on the field that has a lot of sensors. Signals, again, have a primary key with an ID. This is very important because the idea is to optimize for storage. It means that when you relate to an installation, you say an int ID, and when you relate to signal, you also use an int ID because that's usually what's most efficient in storage and to make joins, and it's less error prone than names. However, a name is also quite important because it's usually what people use to search through the catalog. So you have also a unique name. In a sense, Signal has two primary keys because you have the unique ID, but names are also unique in the field. And these signals belong to installation. This is also something that we can do through Postgres and TimescaleDB because it's a relational database, something that you cannot make in some purpose-specific DBs. Also, you can, the same idea propagate this. Along your installation table, you can have several other tables providing metadata to those particular installations, depending on what kind they are. And in Signal, you can do the same. We have another table, which is Signal Meta, for example, that has specific values related to the signal. For example, ranges, data types, the units. Units are important because some instruments measure pressure in one way, and some instruments use another unit. That's quite important. And the meat of this is the sample table. If we can, there we go. The sample table, which is our Hypertable. The field is quite big, so we have various databases storing sample data from different kinds of installations. So our installation catalog is unique across all databases, and it's replicated across all databases. The signal catalog belongs to a specific database that stores some specific kind of installation, because that kind of installation is also what determines what if it's important or not. There are some installations that are way more important than others, so some databases are way more critical than others. And in the end, each database has the main hypertable, which is sample, which has a few very specific quirks that I like to mention. First is the ID of the sample. Again, the signal catalog uses an ID as primary key, which is a simple int8. This is optimized for storage, so your foreign key, you only need that int value to identify it. Timestamp with time zone, obvious reasons. Quality, which is something that your model might have or might not. The thing with quality is that it's quite common in industrial protocols to have a quality value, which usually means that communication got down. So you get maybe a 0 emitted with bad quality, and you can derive the communication status from looking at some signal. And the three specific values here, like why is our value separated by data type. Usually, at least in our testing, this might vary depending on your data or what data you are storing. It compresses better. Floats, ints, or rather, booleans compress better than ints, and ints compress better than floats. So if you optimize for storage, it's a good idea to separate by data type. We haven't seen a lot of improvement from even segmenting by more specific data types, because you can have an int2 column, an int4 column, a float 4 column. That's not it doesn't make much of a difference. But like at least these three divisions where you have a sample that it's a pressure, so it's a float, and you can have another sample which is an alarm, so it can be a boolean, activated or deactivated. It's quite important. But you have to take in account that you are adding, in theory, you are adding overhead by having 3 columns, new label columns, instead of one value. What we have noticed is that compressed chunks are quite efficient, because in one segment, which we use the signal ID as our segment, if all the values in a column are null, you only have one null in the compressed chunk. This is quite efficient because you look at the compressed table underneath, and you only see the values that are present for that sample, and the rest are so null. You don't have a million nulls repeated and somewhat compressed in a single column. So this schema has been quite efficient. And then you have, depending, An obvious issue for looking at this is that when you query this data, you have to know what kind of data you are querying. Because if you have a pressure, you have to query a float. If you have an alarm, you have to query a volume, a boolean. That's a big issue because you are putting quite the responsibility on the people that are querying the data, and not all people care a lot about the data type you are querying. A lot of people are simply doing some mass analytics that are grabbing a lot of different signals. So what you can do to simplify this table is to add a simple view that coalesces all of these three in a single value. So if the engineer that is doing the analytics is sample a boolean, they'll know that 1 is true and 0 is false. And if every other signal, they can just treat it as a float, and it will work the same. This is quite important because you have a view that provides a simple interface for people that don't care about the data type underneath. But if you have people that use the bits of an integer signal, for example, because they are using some set flags or something like that, where you can't transform the value to a float because it might cause issues. You have in the original sample table, you have your entire column, so you can operate with that if you need specifically that kind of data type. That's overall, that's basically the basis of the schema. Of course, like I said, the idea is that you complement this with the specific metadata and catalogs you need for each kind of installation. So in reality, we have like management systems to manage wells and to manage station and injection plants that are built on top of these four tables that compose or most basic level of the whole schema. And there was a question to close. There was a question in the chat that says, "What kind of protocols do people use between the sensor and the database?" I think. I'm not sure if it was directed to everyone or to this, but in the case of industrial,
to share.
Yeah, sure. In case of oil and gas, industrial protocols are quite common. So you have OPC, OPCDA, OPCUA, and variations by vendors. Vendors add extensions to these protocols to handle specific cases of various installations and controllers in the field. So you need a special gateway that knows all these protocols. From there, we build upon base free standards, which means that while the gateway uses all these quite expensive protocols, from there we build on top of MQTT and relational databases to basically build a solution that is as low cost as possible. It's a big problem in this context to say, all right, I have 100 sensors, but I actually need 200. And if you have a contract with the usual vendors in the industry like Siemens or General Electric, or that kind of software usually is quite expensive, and you have to sit with these people and say, all right, I need a contract for 100 more sensors in 500 installations, and it's this kind of is a lot of money. Instead, with this kind of solution or built on open source software, that's not a question. You only have to think in storage, which is great. Like it changes everything inside the company.
That's so great. Thank you very much, Facundo,
for having me.
Yeah, thank you very much. And if anyone would like to actively participate in the next sessions, we have a main subject, but we always welcome people, and we really want to have like community voice here. So thanks again. moving on, more examples. So this is a few more examples that we are going to bring now. Just like this one is very inspiring. This one, I guess, is also like a production proof already, so it's very important. And if we go into this direction of also a narrow table generally means like a simple table which you have like a metric name and a metric value. And this is a like a generic metric system that you can just make it very dynamic. So it's very good. It has a great performance, and it's also another alternative depending on what you build, right? And this will give you like this data input flexibility. So you start with like your identifiers, and maybe if you expand your business, like you add more sensors, maybe you create like a scope, or you can keep nesting things, or even change the table and add more information. But this is very, very flexible and quite easy to come. Another alternative is when you think about like your data has different life cycles. So let's say, for example, if you are looking for temperature, maybe you are building a system and you have both temperature and humidity, but your system is very, very focused on temperature, and humidity is just there. So you have a different data life cycle. So your data will be there for less time, or your data will have a different density. So I don't need like a humidity hour by hour. I can have it every 4 hours, or oh no, temperature I need to have like an every 30 seconds. So depending on how you are going to need the values in your in like how much you use, and how much dense is your data, and how much you need this let's say amount of samples in higher quality will define how also you can also build the tables. Because if you mix data from different sources that have a very different level of density, maybe that will also have some different outcomes when you query the data for specific types of values, right? And you can also think about like data type flexibility, as Facundo built everything in a single table with all the tips and tricks on just switching the data types. I'm very curious to see a benchmark on this thing, because I never tried this, but I can probably imagine that it's a very cheap change of keeping the columns now and just to like fill the values on what you need there. So probably it's very optimized. I really learned from this tricky, and I hope I can benchmark it at some point too. And this is another model. So this is like just a few other guidance that can help you to think on how you can do this. And naming is fun. So if anyone would like to share, like we talked about sample, signal, events, messages, weather data, sensor data. So naming is always a very, very hard thing. So if you want to share your experience naming your tables, that's just for fun. Like if your business, if this does not affect your business, this can be also a good thing for folks. Maybe they really don't have like a standard, and it's great when we are in the same industry that we can think about standards. So is it better to have like a subject or something? So that's how it should work. And so we have too many options. And this is like a session that I made for building a template. And we are not like really building the template here, but we are just looking all the options, everything we have, all the possible scenarios. And then you also think, oh, this looks more my scenario. This is like a mix of ideas that you need. So we started with this pull request that is a request on the templates, and I have it open here. So basically, you can also take a look here. We have this add sensors kickoff that is here, and we have the main file here that is supposed to be like the start for folks that want to be starting with the sensors data. And the idea is that people can just choose what model they want. So for now, I put like the main sensors.sql file as our start here. And the cool thing I think we could learn here is from these setting variables that you can make on pSQL. So if you load this SQL file via pSQL is like a tool. You can say pSQL in the name of the URI of your server, and also some file, and you can run some SQL file inside your server. And this is like a plain SQL file, but you can also do this \set that allows you to create variables. And these variables can be, for example, in the first case here, it's the reg class, like the Hypertable name. And you can see here, I can do like a column Hypertable, and it will just reuse the name event. So this is like a templating system, which people could just say, well, the name of my table is events, my chunk interval is 1 week, I would like to have continuous aggregates on this, and that intervals, and then we can just say, well, here is our pipeline script, and you can run based on your sensors model. So the idea is that if we make it configurable, at some point we can also just like cherry pick what model file you can do it, you can use for your case. And if a few folks are interested in keeping it like together, or even adding more extra functions or scenarios that make sense for IoT, more than happy to add them, right? So we have this. I will also be covering a few more scenarios here. So we just leave the same default chunk time interval. We also have here continuous aggregates. And this is a work in progress, so that's why I didn't merge the PR, but I am trying here to create like a recursive process, which interactive process, which I go over the list of time frames and generate the view, which will be made by one name here that is like Hypertable name and the time frame. So, and the idea here is that we can use the stats So for example, here we have like a payload temperature as like what we want to put in our stats. So we could put more data there. And then as we want to use the hierarchical ecosystem, we can also use row up. So this is for folks that are not familiar. Let's come back here. We are going to be having an entire session about this hierarchical continuous aggregates. That is our next session, but we will cover a bit more here soon. So let's talk a bit about chunk time interval. That's like the most common question, so I also brought it here. We are not changing the defaults, that's 1 week. And people are always looking specifically for this recommendation. So in the past, we had a blog post which says like, perfect size for your chunk time interval. So we try to bring a recommendation, and our official recommendation is every chunk should be around 25% of the RAM memory. So it means like, well, if I have 8 gigs, maybe I put like one chunk of 2 gigs, and that's a good size that allows you to play with 3 or 4 chunks in memory, and then you can keep like loading and unloading this memory depending. But it depends on your use case, how you are going to query your business, and how much data you have. So chunk time interval is all about cardinality and density of the data. So cardinality means how many devices are sending data to my system, and the density means how often they are sending this data. So if you combine these two, you understand your throughput, and understanding your throughput will let you understand if it's becoming too large or not. So I would recommend you don't worry too much. Just make it 1 week and try this out. And then if you see that it's a serious problem for you, if you have like a very high density of business on your business, maybe you get a shorter chunk. What are the effects of having more chunks or less chunks? So if I have more chunks, I will have more overhead on navigating the chunks. So let's say if I have one chunk per day and I have 50 years of data, so I will have thousands of chunks to find the perfect path for what data I want inside. So if I'm getting more large spaces of data, maybe these smaller chunks will make it open and close to many files, or like you need to think about the types of overheads that fragmenting things have. And in the other side, they are easily and faster compressed and decompressed. So you also have this in a more manageable size. So you need to find, we couldn't say still like, oh, 7 days is perfect for it rules our business in the world, but we can still think that we are in a progressive dynamic chunking a saga that at some point Timescale will be able to solve this problem. Like, hey, how how you want to consume, like it's like a thing that we are aware that we want to improve as a business, as a part of the core, but this is a very hard problem. It's a very complex problem. So if you have ideas and want to bring like, hey, here is my scenario. If I would implement it internally, I would do this, and that, and it would be great resource for the core database engineers here that are working on this type of algorithm. So it's a very important thing for the entire community. And if you have ideas, come with them and let's share, let's talk about them. That's a very important part of the business. If you are interested, take a look on dynamic chunk sizing, Timescale, GitHub, just search it and you find your issue about it. And you can take a look on a few ideas that people are a few years talking about it already. And that's a long saga. So this is a thing that is still on manual, but at some point I hope we will have a co-pilot helping us to just make it fast. So compression, I just use the variable names there that you can configure in the previous file. So maybe that's like confusing here. But for enabling compression, you just need to do this outer table in your Hypertable, and you need to set this configuration. So if you're not familiar with what compression can do, imagine that you split your data into these chunks, and then you can compress the chunks independently. So let's say you have 1 day of data and you have like 100 devices. So you segment by each device, and then you can just compress the data by device and make it like an array of values, like an array of temperatures, an array of whatever you have there. And then you can compress this array. So we see folks reporting like 95, 97% of savings using our compression system. So if you never tried, give a try. That can be an option. I'm not going to be very deep here. In the last session, in 4 weeks, we are going to cover only compression and retention policies. So you can learn all details about it and how the engine works and so on. So just one small reminder, if you enable compression, it's very important that you set order by and also segment by. So these are two options. They are not mandatory, but you should probably configure them because it can make your performance boost in several ways. So when you have sorted data by default, you can predict how to traverse the data. If the data is not sorted, you cannot predict. So you need to go line by line to guarantee you have the same consistency. And if you don't segment your data, so maybe you lose a lot of opportunities that compression brings. So compression also can run in background. You can set up like a policy every after 1 week, your data is there. It's not very useful, so you can just compress the entire chunk, and then you can follow. If you want to share your settings, how are your learnings on compression? Compression is a big beast. Just think like when you reach like terabytes of data, but you don't have terabytes of disk. If you are saving 95%, you need to be very careful how you enable compression, how you use it, because maybe you have to dance between your disk size and how much data you can trade on compressed versus compressed. So that's a very important thing, and it's also interesting to remember. About hierarchical continuous aggregates. So basically, we have continuous aggregates that works like a materialized view that allows you to let's say, processing background data that you need for your dashboards or anything that you want to process in advance. So I just put here the time frames, like 1 month, 1 hour, 1 day, 1 minute, sorry, 1 minute, 1 hour, 1 day, 1 month, and 1 year. And I'm curious to know, what do you have in your configurations if you are already using hierarchical, if like it makes sense, these frames for you, and how they work. The next session will be all about continuous aggregates, so I will not be sharing too much, but if you want to just share what do you have in your config, maybe we can also use for the next session, and we can also make the next session even more fun, understanding how people are using. A few things that I would like to wrap up here is the trade-offs that we have in performance when we choose the timescale features. So when you use compression, you are just trading disk for CPU, right? So you have a short disk space and you spend more time processing. Sometimes you have much more idle CPU than idle disks. So it makes sense that you do this mix. And continuous aggregates is the same. Like you have like a predictability that your queries will be running and people will be asking for such information. So you also prevent from like having huge access to the raw data, and you just leave it already processed for the end user. And I would recommend you take a look on how is the average of your queries per second, and what are the most frequent queries? Are they good candidates for continuous aggregates? Are they like good candidates to be pre-processed or at least partially processed? So soon you get into how it works, you start looking like how you can make your processing layer very smooth and more clear. In the next session, we will really talk about the processing pipeline that hierarchicals bring to the scene, and I'm just promising it from the title perspective, but this is also a hook for getting folks for the next session. So I hope you don't mind, and it's also because of the amount of time we have here, right? So the next session, hierarchical continuous aggregates. The other one will be about query performance and downsampling. And the latest one will be about compression and retention and how to implement policies, how background workers work on Timescale, and so on. So for just a sneak peek of what you can expect for the hierarchical continuous aggregate session, that's a much more, let's say, deep and technical session about understanding the materialization engine, understand how the materialization works, what type of metadata it moves when you touch your data, and how it works when you just ask to refresh the data or if it's done in background. So we will be covering all the settings and details, and that's a very instructive session as well. And I hope to see you there in our next session. So now I will open the space for some questions. I guess we have like like 4 or 5 minutes until the next sessions. And if anyone would like to bring anything special, I don't know if we have any special question that we could bring from the chat. Yes, I see also folks from commenting about tags and the usage of tags. It's also very, very good use case. I remember Timescale also implements the tag system into all the metrics. It's amazing and so simple. Yes. Okay, so if anyone has any other questions here that would like to bring, I see Daniel and Facundo are sharing. I think we can also continue these types of conversations later in our channel. And we have the discussions, the sensors discussion channel. And also, if you are not on our TimescaleDB Slack, just join us. And this is also a good call for Timescale office hours. So I am developer advocate here and I run the office hours. We also have James in Australia and I am in Brazil. So if you want to have a 1 hour talk with us about anything Timescale related, just book a call. You can find the links for our shared calendar there. So you can just find one slot that works for you. And thank you very much for this session. Thank you very much for being here with me. And I hope to see you soon in the next session.